What is up, you guys? It's Hamid Abdul, and I'm back again with another Unity tutorial, this time part 9, but I wanted to make a quick PSA. So this whole entire project as of far is on GitHub, and so will this episode and every future episode, so sorry about the misconvoluted confusion last episode, but anyway, yeah, I'm just really new at this and I'm sucking so bad, but hopefully I'm bringing some value to you guys, and that's all that matters. So without further ado, let's get right onto the Unity tutorial. Anyway, what we're gonna do is go over to Unity, and if I can get my mouse aligned. And basically what we're gonna focus on in this episode is our Koopa shell and getting it to move and interact with our player. So with that said, let's go and create a shell prefab. First, let's go to a Koopa Troopa. Let's make a copy of this. Oh, sorry. Let's make a copy of this. Let's name this Koopa. Let's go here. Let's get rid of all the here. Let's get a better view in the scene. Move our transform over here. Get rid of both the head and feet. Yes. Go over here. Edit. Let's delete both of these. Just delete both of the box colliders. Let's remove the enemy movement script. Keep the rigid body. That's fine. That's fine. Enemy damage. That is fine. Let's go to add another box collider 2D. Okay, that's what we're gonna do. And from here, I'm gonna let's change this. Sorry, to Koopa shell. Drag this to our prefabs. Come over here, back to our Koopa Troopa. Let's go to our enemy damage script. Oh, sorry. That was in mute of it, but enemy damage. Let's open this up. And basically what we're gonna do is we're gonna make we've already made a prefab, and what we're gonna do is in our script is instantiate that prefab every time that a event happens, and basically we want that to be on collision or on trigger in this case, but not necessarily in the instance of colliding at certain points. So we'll get to that, but without further ado, what we're gonna do is make we don't even need this line, really don't. I don't think we do. Yeah, it should be okay. Yeah, we do, yeah, we do. Sorry. Oh, no, we don't. Just go to this line here that says destroy player and go to game object. And that fixes itself. Go back down here, and basically we're going to make a public game object variable that we can assign our shell prefab to. We're just going to name the shell prefab our public game object shell prefab, and then from there going to go down to our on trigger enter 2D function and change these two squiggly lines from oh no's to destroy to basically what we're doing is on here we have a object, and let's call this our shell, and then we want to be able to instantiate this. So at that we're going to pull from the public variable that we just made, shell prefab. Now we need a position. Let's say transform position, comma, and then a rotation transform rotation. Okay. In here, let's add comments because it's good. On the instance of trigger collision, a shell prefab is instantiated. Oh, also this is not it. So basically what we want to be able to do is we have to not only instantiate but destroy the current object. So we're going to destroy this game object. So we're going to destroy our Koopa Troopa prefab, our instance of Koopa Troopa prefab, and then we're going to create an instance of the shell. But that's going to happen before we destroy it, so the player hopefully doesn't notice any gaps. It's going to be predicated on your settings and your how you're going to export things, and this probably wouldn't be idealistic. You'll probably want to optimize if this was a project that you were shipping or publishing, but for the sake of this video, this is everything that we need. And yeah, player is instantiated and Koopa Troopa is destroyed. I spelled destroyed wrong. Sorry. Okay, I'm gonna save this. Go back to our scene. Let's go here. Let's try this out. Hopefully we can not succumb to the... We died. I don't know if that's a bug or if that's supposed to be that way. Usually we don't die. No, we died again. So, okay, I goofed up. Basically, you want to switch these two lines, and with that, you'll be able to kill your Goomba, and you won't have any problems or have to make a separate instance of this script if you're destroying the object first and then instantiating the shell, based on if they have a shell prefab entered in the inspector. So we're gonna go to our Koopa Troopa, gonna go down to the enemy damage script, go to our prefab folder, drag and drop the Koopa shell, well, that's a shrub, sorry, Koopa shell into the shell prefab slot, go to apply, and also with the changes that we made to our Goomba collider, go to apply if you made those changes. And if you didn't, and you're keeping up and downloading things on GitHub, it will be as you're seeing them happen. So yeah, and gonna go here again and give that a try so I can show you guys. Gonna go here, bam, bam. Okay, where's the Koopa shell? I don't like where, I don't understand. Okay, apply Koopa shell. You delete the instance of the Koopa shell that's in the scene because we don't need it. I'm gonna make the friction from this a little easier. I'm gonna change around the scene just a bit. Gonna create another copy of the player. Player 1. Move player 1 over here. Move player here. All I did was disable the first instance of the player and disable the instance of the Goomba. Drop. See if... Okay. And basically with that, we're... I don't know why it's not letting us... Okay, not only, so basically it's killing us when we collide with it. It's not what I want to do. So for now, I'm going to disable, gonna remove the enemy object, enemy damage script off of the Koopa shell. Okay, that's what we want. And let's see if, okay, now we're gonna move this back. Just get a feel if things will work outside of. Okay, things are working for there. Alright, now what we want to do is we're going to want to, this is where things get really tricky, really tricky. Basically, we're going to use our enemy movement script as a foundation, and we're going to not only use 2D physics, but we're also going to incorporate 3D physics because we want to be able to tell which direction or side the shell was hit from. That way we can determine its movement, therefore on, and it properly interacts with the player in just like in the original game. And with that, without further ado, let's go right on ahead and create a Koopa shell script. So we're gonna go to our prefab, go to our shell, gonna add component, Koopa shell script, and then with that we're gonna create an add. Gonna open it up. I'm using Visual Studios, by the way, and if you wanna know how to do that, there's a link to it in the very first episode, or you can just search up Unity 5 and Visual Studio integration, and there you go. There's a Vietnamese lady, and she's awesome at teaching you how to do that. So anyway, okay, Koopa shell script, where's it at? Why did it not open? Okay, there it is. So we're gonna go here, I'm gonna bring this down because I just like the symmetry. Get rid of everything in the script, and also we're gonna go over here to our enemy movement script, Control C, go back over here, shut up phone, Control V, and basically with that we're going to go down the ranks and scrap everything we don't need and be able to build off of what we do need. So from here, we do not need a player float speed determined. There is some way you can implement that, but we're going to be using a physics. We're going to be using physics mechanics of adding force, a constant force at that rate. And yeah, just to keep things, I wouldn't say simple, but idealistic, we're gonna go towards that way. So get rid of this line, Control X, my trans, do we need this? Yes, we do. My width, my height, rigid body, my sprite. Now, do we need my sprite? Yes, we do need my sprite. We're gonna go on further. We're gonna skip down to the fix update section. What we're gonna do here first, so we can avoid every possible potential problem and dilute ourselves, because I've spent weeks trying to figure this out. I've been to multiple forums, and some people have not been the kindest in helping me. But what we're gonna do right off the back is change this up, from fixed update to update, and with that it'll allow us to actually keep up, because you may have a computer that's so fast that fixed update and the physics that's going on are don't even it's not even, or it's exponentially slower, so you'll get this stutter effect, and the mechanics and the way the game was the way that you're scripting won't be implemented properly, because the game isn't updating frame by frame with your system. It's updating based on the physics system, and it's just not idealistic. And there's been times where, let's just say our Boolean checker is blocked. The shell would be moving so fast that, or not really that fast, but the shell is moving so fast that the physics system can't keep up with it. So my Boolean line cast is not even attached to my game object, and it's just terrible. So right off the back, we're going to avoid this, keep things on update. Now there might be some optimization reasons behind this, which I do not know, because I don't know how to optimize in Unity, because I do not have a license, have not learned, and obviously if you haven't been able to tell from the organization from these videos, little expertise. So yeah, without further ado, just keep things update, not fix update. Gonna go here, and we're gonna want to save our script. And with our ignore layer collision, we're gonna want to make a new layer for our shell. And with that, what we're gonna do is go here, because technically our shell is a very unique game object, because not only does it harm the player when it moves, but it also can harm other enemies, and that's the beautiful thing about that. So we want to make this its own layer. So Koopa shell, for me, it's going to be layer 11, and if you've been following along, it's going to be layer 11, or if you're downloading on GitHub, it's going to be layer 11. So with that, let's go back, Koopa shell, put it to Koopa shell layer, as well as we're gonna, so there's enemy in the level boundaries, and if I recall, enemy and level boundaries, it's gonna be 8 and 9. I just want to make sure, I don't want to take my word for it in the script. 8 and 9, okay. Just wanted to make sure. Power-ups are avoided by Koopa shells, if I remember correctly. So 8. What we're gonna do is Control C, copy that, and then paste this line, and then change this from 9 to 11, and 8 to 9, and then change 9 to 11. Save our script. Now, line cast posh dot our extents are being updated. Start. What we want to do is get rid of the Boolean flag is blocked. Well, it's usable, but the thing is blocked is not really specific in what direction it's being hit. We want to be able, and what we're going to do is create 2 new variables that'll be able to tell us which direction is being hit. But until then, we're going to delete this. And we're going to delete the rest of the script. So from if is blocked to the rigid body dot velocity equals my value, just delete it. We do not need it. Control delete to get rid of some of this empty space. Okay, now right from the beginning, like intended, we want to be able to basically, we want our player to be able to interact with our script or our Koopa shell on the premise that it is moving, it will damage both enemies and players. Now, on the premise that it's standing still, nothing's going to happen, but it'll be initiated to move in the direction corresponding to where the player hit it. So if it hit it from the right side, it's going to continue that movement onward. Hit it from the left, going to continue that movement onward. With that in mind, we're going to create quite a few flags to help us identify and communicate that effectively. So right off the back, we're going to make a public boolean. That way we can see not only is it checked, but other scripts can see if it's moving too. We go public bool moving. Now, under here, we're going to create 4 booleans. They're going to be shell left, shell right, right blocked, and left blocked. We're going to create a public float variable, and that's going to be called raydiz, and this is going to be the distance that our raycast is limited to, because rays can cast indefinitely, and we definitely do not want that. We're going to go here, and just for the sake, because I'm kind of a OCD freak, let's switch these 2 lines. So totally up to you if you want to do that. You don't have to do that. So we're going to make a box collider. This goes back to what I said, that we're using both 3D and 2D collision systems. So we're going to use a box collider, and we're going to make another box collider 2D variable. So this goes back to our 2D. It's gonna be basic B col. Let's just call it B col. Oh, don't forget your semicolon like I did. And this goes on to what I was saying about the constant force. So what we're going to do here right under the B col is we're going to define our constant force variable. We're going to just shorthand this. So constant force 2D CF. That's it. CF, constant force. I'm going to tidy this up just a bit by putting these in alphabetical order so it's a little easier for people to follow. QRS, okay, just making sure. Alright, we're going to save our scene, and without further ado, we're going to get right on to putting these variables to use, because most of these are shorthand variables. So what we're going to do is we're going to go right into our update function, because everything that we need is in the start, so we can might as well just close this. I'm going to zoom in just a bit. We're going to go right on along. So first we're going to define CF. So CF equals game object dot component constant force. With that said, we're going to have to go on and add a constant force component, or else this is obsolete. So, but the reason that this is defined in the update function opposed to the start method, or the start function, is because we want this to constantly update. So with our comment, I'm going to put a shorthanded variable that is constantly updated. Sorry, go back and then here. Just create a space between here. Alright, and now what we're gonna do is we already have our ignore layer collision. We already have ignore layer collision. What we're gonna do is create a we're gonna go to our shell prefab, and within that we're gonna add a constant force 2D component. And with that, we're going to leave it blank. We're going to leave it how it is. We're going to go back to our script editor. And now we're going to continue on with everything we need. Okay, so for the purpose of keeping this video short and consumable, we're going to stop here, and this is where we're going to cut off, and right before we get into defining and laying out the exact things that need to happen with our 2D and 3D collision. But hopefully this was some help for you, and this has laid down the groundwork for something that will be lots of fun. I'm looking rather forward to. So anyway, thank you so much for watching, and this whole entire episode will be available to you in GitHub. So I'll leave a link in the description below, and be sure to leave a like, comment, and subscribe, and let me know some things that I can do better to make these videos a lot more smoother, or just anything. Just literally some feedback or criticism will definitely help. Anyway, thank you so much. I will see you guys next time.